concepts that we use to understand the previous classes. Okay, so we're going to talk about surface and interfacial tension. In this situation here, in this artistic view, we have a preempted glass, and it has vacuum in it, and we add a D-nipple at the bottom, which is called D-nipple. Could be any nipple, because if it's a vacuum, it's gonna sit at the bottom anyways. Well, you see the shape of that. As this D-nipple volatilizes here, you see the D-nipple filling the vapor here, creating a D-nipple vapor in the zone. So we have a liquid phase in the same bottle as its own vapor. Well, the shape of it, right, is determined by how the molecules tend to stay. The molecules tend to stay together. Okay, and this is called, when it's on a zone vapor, it's called surface tension, not interfacial tension. Surface tension. And the question is, when it's in its own vapor, a fluid tends to a stable form, mainly spherical. Of course, it's not spherical due to gravity effects. Why does a droplet tend to stay that way? Well, let's get a different situation now. In this situation that we see here, now we have a droplet of the nipple, and in our vial, instead of vacuum, now we have water. Well, this D-nipple will have some molecules dissolved in water, forming a dissolved phase here, and we have a droplet of D-nipple that tends to stay mainly in a spherical form again. When in water, immiscible, denser fluid tends to a stable form again, spherical. See, we don't have porous media here. We only have two liquids, the D-nipple and the water. Well, when the fluid is immersed in another fluid like this, we have D-nipple and water. This is called interfacial tension compared to surface tension. Interfacial tension refers to two different fluids in contact. When talking about surface tension, it refers to a fluid in its own vapor, okay? A liquid in its own vapor. This is a different concept. For us, we're going to be dealing with interfacial tension throughout our course, not surface tension, okay? Again, the question, why does a droplet tend to stay this way? Well, a droplet tends to stay this way. Why? Because they tend to stay attached to their similar. The tension arises between the two phases when a fluid is in contact with its own vapor, and it's called surface tension. Well, when a liquid is in contact with a different fluid, be it gas or liquid, the resulting tension is called interfacial tension. Well, now we'll take a look at droplets when they drip and they tend to separate from the fluid, like this one here. See, droplet here, and they tend to separate from the fluid that it's in. Well, the shape of that relates to its interfacial tension, because it tends to stay with its own molecules, the molecules that are alike to each other. So they tend to stay together. When it drips and it separates, that's related to interfacial tension. So different fluids will have different shapes due to their viscosity, density, and properties, okay? So we see this picture here as it moves. Well, in the next class, we will see then how this applies to our major concept. And I want you to make sure you see these videos over and over again. Thank you.